Hey, it's Horner, and this is for AP Physics C, and this is 1986 M1. We have an 80 kilogram person, and we have a 20 kilogram cart. So this entire thing we know is 100 kilograms, which is kind of cool. And this person is pulling down on the rope, and when they pull down the rope with just enough force, they stay steady. So it says if the platform and the person are at rest, so there's no acceleration, what is tension in the rope? So we know that A is equal to 0, which means that the sum of the forces have to also be equal to 0 since there's no acceleration. Let's go through and draw a free body diagram for the person and the cart. Okay, so this is the person and the cart together, so this is mg. There would be a force of tension coming up, and then you can treat this rope like it's attached to the cart, even though it's attached to the person, because all it's doing is just holding the person and the cart up. Okay, so that's really all that's happening here. So ideally, all you're going to have on this side is just tension. This is different than if, let's say that we had the same situation. We had the person in the cart, and they were just in the cart, and then this came up and came back straight down. Okay, there's our pulley there, and then you had a person pulling down. Things would be a lot different. Our tensions would actually be opposite of each other, so you'd have T minus T. Because this dot really emanates from this dot here, we can actually say that this is just one big thing. And now you actually have two tensions pulling up. So we're treating everything here as one thing. So we actually made that dot really, really big. All right, so let's go ahead and do all the sum of the forces. We see that going up we have 2 times T, and then on the way down we have mg, and that's equal to 0. So 2 times T is actually equal to mg, which means that T is equal to mg all over 2. Mass for the whole thing we said was 100 kilograms. Gravity is 10, and then we're going to divide this by 2. So 100 times 10 would be 1,000 divided by 2, and that gives us the tension in each rope of 500 newtons. It's similar to just a person hanging by 2 ropes. You just divide their weight by 2, and that gives you the right answer. This part is actually worth 4 points. You get 1 point for saying the sum of the forces is equal to 0. Really important that you show all your work, because if you don't show that, things don't work out really well. You get another point for doing this equation. Okay, so having the equation here as a point, filling it in as a point, and then right answer with the right number is also a point. But other than that, that's really it for part A. For part B, we have the person now is pulling on the rope. So now we've got tension going up. We also have another tension going up. We have mg going down, but we have the person pulling on the rope, and it makes the whole thing accelerate up. So don't worry too much about the person pulling the rope down. That's not the point. The point is we've got this this acceleration making that whole lift thing go up. So the sum of the forces now this time are equal to mass times acceleration. What are the forces? We did this last time. We said it's 2 times T minus mg, and that's equal to your mass times acceleration. So now we have 2T is equal to ma plus mg, which means that tension now is equal to ma plus mg all divided by 2. Mass of the person and the crate is 100, so 100 times 2 plus 100 times 10, and then we're going to divide that by 2. So at this point, we have 200 plus 1,000 is 1,200 divided by 2, and so now we see that the tension in the rope is 600 newtons. Okay, so each rope now has a tension of 600 newtons. That's going to be important in the next problem. Before we go there, let's just check on the number of points. They give you a point actually for making sure you have this in the right number associated with it, this and the right number, which would be here, this and the right number, which would be here. And I know I said number, you just got to solve for the t, and then you end up with 1 point for the 600 newtons. And so that is part B. For part C, they change it up a little bit. Now they want to know what is the force exerted by the platform on the person. So we're going to go back up here and take a look at this. So the force of the platform on the person. We have, let's redraw just this part. We've got the platform. We have the person on the inside. They're smiling because they're happy. We've got the tension in the rope up. And now we've got something else. We've got the force of the floor on the person. We've got the person. It's their center of mass. And so they've got mg going down. Here's the normal force. And then here is the force of tension. So if you drew just a one dot diagram, just a free body diagram, this would be mg. For the person, we would have tension acting, and we would also have the normal force acting. So they want us to find out what is this normal force. But we have to remember that this thing is also accelerating up. So the sum of the forces for this one are equal to the mass times acceleration. This time we only have one t going in the upwards direction, but we're going to add to that the normal force and subtract from that mass times gravity. And that should be equal to the mass of the person times that person's acceleration. So we're going to actually put mp here because we're really just looking for the person and not the whole system itself. We know from earlier that the tension when it was accelerating was 600 newtons. We don't know what the normal force was, but we do know the mass of the person. That's 80 times 10, and that's equal to 80 times 2. So let's go ahead and do some math here. We've got 600 plus n minus 800 is equal to 160. Let's go ahead and add the 800 to both sides, so that'd be 600 plus n is equal to 960. So now our n is equal to 960 minus 600. And at this point we end up with 360 newtons is the normal force on the person from the elevator floor. And for this one you actually end up with 5 points. You end up with 1 point for making sure here that you have something to indicate the normal force, something to indicate the tension, something to indicate mg and ma, and then you get 1 point for the actual answer. So if you've taken AP Physics B, for those of you that have been in there, the two of you, notice the points are a little bit different than what you've seen before. And that is the end of 1986, number 1.